So to start with, the first issue itself, what we are going to do is we are going to talk about a definition of statistics, because many times we think that statistics is only analysis, but unfortunately it is not. Statistics is concerned with at least 4 types of issues, and it is a process, not one time ending. So that means what? It has got 4 stages. When you perform a statistics, we are getting into these 4 and we are going to discuss in detail, especially the third section. So the first concept or first process is the beginning of statistics, where we are going to collect the data. So when you talk about data, please understand that data could be either primary data in nature or it could be a secondary data in its nature. So the basic difference between these 2 types of data are a primary data collection, where it is called as first hand information. As a researcher, you go to the field by yourself, you involve yourself in data collection, and you bring the data through several methods, through questionnaire or through survey, through observation method, or using equipments. So whatever the things could be, where you are going to collect the data by yourself, where the serious involvement from the researcher side is important here. Whereas there's another set of data which we use in social sciences is the secondary data. Now remember, secondary data also looks like primary data, but that data is not collected by you. The secondary data is collected by someone else, but you can reuse them, you can recompile them as you as you wish later, according to your objectives and hypothesis. So that is why the data collection, first you have to be clear. Are you going for a primary data collection technique where your involvement is more, or are you going for a secondary data collection technique? Both are equally important in research, because sometimes secondary data gives you a lot of inputs regarding your study area, or regarding your research question or problem in hand. But remember, secondary data, you cannot have any control. That is a basic issue. Whatever the data is being supplied by the concerned agencies. For commerce people, it could be Sensex. For arts people, it could be population data, where it's all available online or offline in some of the offices or the institutions where you try to collect the data, but you have no control over that data. Whereas in primary data collection, you have the control of the data. If you think that your sample size is less, you can go back again and collect the data. So that's a basic difference between the collection data in primary or secondary data techniques. Then comes the compilation of the data. So it is not just enough if you collect the data. I think if you are not still well equipped with the research methodology, and those who are still not pursued or PhD or planning for PhD, please see to that you need to consult a statistician or a research expert for your fulfillment of objectives and hypotheses. Because sometimes what happens is, in a hurry you collect the data, but they may not fulfill your title, they may not fulfill even the objectives and hypotheses. You may have to go back again, or you may have to change the title. So that is why consult an expert in your own field, so that at the end you will not have any problem. So collection of data is more important, because in a systematic way, we are not going to talk about how to collect the data. There could be a separate session. But remember, there are several ways of collecting data. Broad headings are primary and secondary. Then is the compilation, where in compilation we talk about coding and decoding of the data, filtering of the data, conversion of data. So sometimes what happens is you cannot use the scores as such. So you have to convert them into some standard scores, or convert them into some nominal way, where you may have to establish norms. So we'll be discussing that today itself under descriptive statistics, how to establish norms and all. So once you collect the data, then you compile the data. Then the major section would be analyzing the data. So once you say analyzing the data, so we have to use both techniques called as descriptive statistics and inferential statistics. So in inferential statistics, basically we talk it for hypothesis testing. So when you talk about hypothesis testing, where we have to either accept the hypothesis or reject the hypothesis, That also will be done through inferential statistics. Then comes for interpretation of the results. That is more important, where we are going to talk about significance levels. So this is where we are going to talk about. Once you start the interpretation, which often leads to the drawing of conclusions. So audience there or the participants there, if you have got any clarification, please raise your hand or stop me so that I can clarify your doubts then and there. Anybody having doubt about the definition of statistics and all? Please feel free to ask.
No, sir. We are comfortable.
Okay, the speed is enough, or should I go a little more vertical fast, or the speak?
The present way is right, sir.
Okay, it's okay. That's enough. Okay.
We are getting, yes.
Okay, okay. So now we'll slowly move on to the types of data. When we talk about the types of data, we talk about an initial level descriptive data, descriptive analysis versus predictive analysis versus inferential analysis. But technically they are called as a descriptive statistics, inferential statistics and predictive statistics. Of course, the predictive statistics word is being used recently. You may not find this kind of classification in the new article, old textbooks. Only in the article, new textbook, you find the wordings as predictive statistics. So what is the meaning of descriptive statistics? Where the second session of the day, we are going to discuss more on that. Our descriptive statistics is a set of statistics where we are going to have the idea regarding the sample we have selected in terms of various parameters. Please remember, descriptive statistics will not satisfy the hypothesis or objectives. Descriptive statistics will give you the idea that what is the nature of the data. That is more important. And what could be the measures of central tendencies, measures of variabilities, all those things which will become under descriptive statistics. That is on the very lower level. Then we move on to the predictive statistics. So in predictive statistics, basically we talk about correlation and regression. So when you talk about correlation and regression, because there is still statisticians have a major objection to add correlation and regression in inferential statistics. So that is why correlation and regression definitely not their descriptive in nature, but definitely they have not reached the point where we can call them as inferential statistics. So that is why between descriptive and inferential statistics, we have predictive statistics. So in predictive statistics, usually we talk about correlation and regression, where predictive statistics can also answer your hypothesis. Then a large section on inferential statistics, where we are going to talk about sure shot tests, where it could be difference based test or it could be relationship based test, where we are going to talk about in detail, where you draw inference from those statistics, where we are going to talk about significance level, probability distribution, all those things. So this is where you talk about the in general descriptive versus predictive versus inferential statistics. Then we have parametric versus non-parametric statistics. So remember, for any qualitative data, we refer it as non-parametric data. For any quantitative data, which is in terms of running scores, we call them as parametric data. For a set of parametric data, you have set standards of parametric statistics. Likewise, for non-parametric data, there are a set of statistics referred as non-parametric statistics, which we'll be again discussing later. So parametric is basically where a set of data is there where you can draw additional parameters, whereas non-parametric, you cannot draw any additional parameters. That's why it's called as non-parametric data. Then you have got univariate versus multivariate statistics. So in univariate statistics, you use single variable at a time. That's why it's called as univariate. So a single variable being used, basically a dependent variable is used, single dependent variable, then it's called as univariate. Then we have multivariate, when you use several variables into a research problem and you start analyzing them, then it becomes multivariate statistics. And then you have basic versus applied statistics, where basic statistics all of you know, but applied statistics, which usually comes for utility in a larger scale, especially for a policy making or for a strategy building or for a public utility cause, where applied statistics can be used. Now quickly looking into the examples for each of them. Descriptive statistics usually refer as tendencies, measures of central tendencies or measures of variabilities. Whereas in the case of predictive statistics, already I said correlation or regression. Whereas in inferential statistics, you can use t-test, f-test, product moment correlation, all those. Then in parametric statistics, as I said, t-test, f-test and all, again, they are called as parametric statistics. Whereas in non-parametric, we use chi-square test, we use Man-Whitney U-test. There are several non-parametric tests are available. We eventually what you call acquire them as we go further. Univariate is t-test and all, whereas multivariate we say factor analysis, multiple regressions where we use many number of variables at a time. Basic and applied already I have explained, where applied statistics where we can use the path analysis and all other things, where these tests will be leading to definite conclusions which may help in policy making and public utility causes. So this is where we talk statistics in different types. Then we'll come to, when you talk about data, please understand the data could be either in the categorical form or it could be in the numerical form. Now the idea is how to obtain what you call the data. Now the mere meaning of data itself is a set of raw scores. Please make a note. A data is equal to a set of raw scores. Several individual raw scores are joined together to make a set called as that set is called as data. And how does this raw scores would emerge? Now these raw scores would emerge based on the measurements which we do. So please understand, when you talk about the measurement, a measurement could be either categorical in nature and or it could be in numerical in nature. So when you talk about categorical level of measurement, please understand a category is a fixed one. It could be a gender. Gender we say category. Gender is not a numerical one. Gender is a categorical one where usually male, female and transgender, if we use three genders, it is not going to be a numerical value, it is going to be a categorical value. We assign values while doing analysis. Male is equal to 1, female is equal to 2 and transgender is equal to 3. But please remember, this will remain as it is. There is no statistical weightages for categorical data. The coding is given only for understanding sake. Then comes a numerical measurement. In numerical measurement, what we do is we assign the values. So for example, if I say population index, crime rate or crimes happening or rainfall, so all that will come under numerical data. So first of all, as a researcher, you should be able to differentiate between the types of data being categorical or numerical in nature. But how to go about that? So to do that, we have what you call scales of measurement. I said data comes through a measurement and how to measure them. So there are 4 levels of measurement. Now, please look into that. Each of these 4 measurements have got lot of statistical significance when we apply a specific statistics. So we start with what is that measurement. So when you talk about measurement, is like assigning the values either numerically or categorically. So as I said, what a scale actually means is that what we can do with it depends on what its numbers present. But remember, when you assign the numbers, it is based on some kind of rules. For example, when you say if you are measuring a trait, then it is what you call, you don't assign the number, you assign the severity. For example, if you go to a hotel and say, how is the what you call, how is the food? You are not going to give a number. You say it's very good, good, bad, worse. You are going to give that kind of category of measurement. Whereas your own scores in net or your own scores in qualifying exams, they act as what you call your numerical data, but they have come through a set of rules. That is more important. So what we do, you assign either numerical or categorical variable based on some standards. Even for to measure height, you use a centimeter scale or a meter scale. You want to measure a weight, you use a weigher, digital weigher. So where they come with a set of standards. So What you do in measurement is you map the aspects of a domain. It could be a parametric domain or non-parametric domain onto other aspects of a range according to some rule of correspondence. Means you cannot just give a weightage value, you have to follow some rules. So in such cases, how the measurement would go? So when you talk about measurement, there are 4 levels of measurement and they are called as scales of measurement. I think already those who are having what you call passed your pre-PhD through coursework and or master degree, you may have what you call undergone this types of scaling. But as for my instruction from the HRDC, I have to talk from the scratch. So that's why I'm starting from the very basic aspect. So scales of the measurement, usually we talk or usually we measure under 4 levels, starting with the nominal scale, ordinal scale, integral scale, and ratio scale. Remember, the first 2 levels of scales are referred as primitive scales, whereas the last 2 levels are called as advanced levels of measurement, because the nominal scale and ordinal scales are still not well improvised. Still the standards have to be fixed. Whereas in integral scale and ratio scale, the measurements are definite. So that is why you have what you call primitive scales and advanced scales. Let's look into one by one each. So we start with the nominal scale. A nominal scale is simply what you call, you assign or designate a number or a symbol to the events in order to identify them. Now, for example, recently you have seen football and anybody is there. Can you tell me Lionel Messi, the winner of the World Cup team, what was his jersey number? Anybody there? Messi's
10.
jersey number.
10.
Okay, Messi's jersey number was 10.
10.
Yeah, I understand. But there is another person in India who also had number 10 as his jersey number in cricket.
Sachin.
Yeah, it was Sachin Tendulkar who had a jersey number 10. But remember, this 10 and 10 are not equivalent. The 10 in football is known for what you call Messi, whereas 10 in cricket is known for Sachin Tendulkar. That means what? Just for identification sake, you just assign the number. Your own names in the what you call HRDC list is nothing but a nominal scale. I don't know whether you're getting the point of mine. And this number is not what you call having any statistical weightage. For example, in cricket, anybody remembers Chris Gale's jersey number? Chris Gale, do you remember his jersey number?
Sir, it is 366.
No, it is 333. It is 333.
Oh, sorry, sir.
Yeah, okay, it is 333. Anyway, I'm not asking any quiz. I just want to make your concept clear. So his number is jersey number is 333, whereas our Sachin Tendulkar's number is 10. This does not mean that the person Chris Gale who is having number 333 is not meant to have 33.3 times more than Sachin Tendulkar. By statistics, yes, 333 is 33.3 times of 10. But this analogy will not hold good. So in cricket, 333 means it is Chris Gale, 10 means Tendulkar. That's all. So, but we cannot differentiate by any statistics there. So the numbers are given just for identification's sake. So try to understand. But why we provide that? Because it provides our convenient ways of keeping track of people. When you say 10 in soccer or football means it is Messi, 10 in cricket means it is Tendulkar. But these two 10s are also not equal. You cannot match Messi Tendulkar or Tendulkar with Messi. So it is only to keep the track of people, identify them, and keep the track of objects or events. And here the numbers are meant only for identification's sake. Not much of statistics can be used here. That's why I said it's a very primitive scale, but it still serves the purpose of measurement. So please understand that. So as what I discussed is some of the categories, like what is your gender? A person can be male, a person can be female, or person can be transgender. Or as I talked about the what you call jersey numbers, how this there are two persons 10 and 20. This doesn't mean that the person with the number 20 plays double of 10. No, it is only for what you call identification sake. So that's the idea. And some other examples are when a person is asked a question, which one of the following media influences your purchasing decisions? Is it TV influences, radio influences, newspaper influences, magazine influences, or internet influences? Now this gives only what you call identification. People might say TV is the most important thing, or some people might say no, for me internet is the thing, but it's all identification sake. So this is where we talk about nominal scale and nominal scaled responses. We'll move on to the possible statistics, where with such kind of data, what kind of statistics can be applied. So in the case of nominal scale, as a measure of central tendency, you can only go for a mode, because we have got mean, median, mode, geometric mean and harmonic mean as measures of central tendencies, but nothing will work out here as a measure of central tendency except for modal value. So mode is the most frequent category of observation, so that can be used as a measure of central tendency. Whereas in non-parametric, one can apply chi-square test. Now you might wonder what you call what is this chi-square test and all. Eventually we are going to discuss about that later. So either non-parametric test, you can go for a chi-square test, or a contingency coefficient called as measure of association. So remember, even at this level, it's a very what you call a very primitive level of measurement. Still people do surveys and other ex post facto research, what you call, when the data are collected on a nominal level of measurement. So that is the idea under nominal scale. So if you have any doubt, I can still clarify. You can raise your hand. We need not wait till the end. Please let me know if you have got any doubts. You can stop me. Otherwise, I'll continue next. So any clarification more required on ordinal scale, or sorry, nominal scale? If there are no questions, we'll move on to the next level of measurement called as ordinal scale. Now, please understand, in the first level, we had just designated the individuals or the objects or the events. But in the second level of measurement, what we do is we put them in a order based on the what you call our priority. So that means what? Now the data is more structured. Earlier that data were haphazardly kept. Now you try to put them in a sequence of your what you call choice, either increasing order or decreasing order. So automatically, since you are putting them into a order, you refer it as ordered scale of measurement. So that is the idea, where you put the things in a order. It places the events in order, but the problem is the gaps between the orders. Suppose you say Sachin Tendulkar is rank number 1, then you say Dhoni is rank number 2, then you say Yuvraj is rank number 3. You keep on ranking them, but difference between 1 to 2 may not be equal to difference between 2 to 3. So that's where the gap differences are not equal, or technically called as the interval difference. So that is why still it is called as primitive scale, because though you put them in the order, but the gaps are not exactly equal between the orders. So that's why it's called as just ordinal scale. And usually what happens is these ordinal scales are used in qualitative phenomena rather than quantitative phenomena. The idea here is when you talk about qualitative phenomena, as I said, some description do you do without any measurement. It's only your what you call subjective opinion or subjective rating. So that is called as qualitative phenomena. You don't give any particular score, but you can just rank. This is better than this. Okay, X is better than Y is better than A is better than Z. You can do only that kind of assessment, but not much. And they have absolutely no values. The real difference between adjacent ranks may not be equal, as I declared earlier also. Then we'll see some of the what you call scaled responses. See the example. How long you do spend reading in newspapers on a typical weekday? So it's an ordered rank, less than 5 minutes, 5 to less than 15 minutes, 15 minutes to less than 30 minutes, and 30 minutes or more. So this is what we say. You just put them in an order, because less than 5 minutes to 5 minutes is less than 15 minutes. The gap is not exactly clear. So that is where we call it as what you call ordered scale, but in between gaps or the interval differences are not same. So you have several examples I have given. For example, school grades I have given, education levels I have given, seniority levels are given, but between these the gaps are not very clear or interval difference are not clear. So this is where it's one of the drawback. So since you have what you call ordinal scale responses, which is one step above than nominal scale, the statistics also would change. So the possible statistics would be the following. So you cannot go for a mean. Please understand. You can go only for mode and the median. So mean is still not we are reached. Mean can be done only at the third and fourth level of measurement. So when you talk about measures of central tendency, the mode and the median are the most meaningful measures here for ordinal scale responses. So that is why many times I have seen the social science researchers, suppose if they have used a survey and they have measured attitude, usually on a 5-point scale, strongly agree to strongly disagree. Some of the theses I have taken I have seen per statement they have taken a mean which is definitely wrong, because it has not reached the level of the next article measurement called as interval scale, but unknowingly we do a mean for the data which is on the second level of measurement called as ordered measurement. So calculation of a mean for a ordered level of or ordinal level of measurement is technically wrong. So please keep in your mind. So in the case of central tendency, you can do that. Whereas in the case of dispersion, measures of dispersion or variability, one can use a percentile or a quartile measure. A percentile is a test statistics which gives a relative position of an individual out of 100. So percentile ranking at where which position he is, or a quartile measure, because in statistics we use 4 quartiles: Q1, Q2, Q3, and Q4, like 25th, 50th, 75th, and 100th percentiles, the technical called as quartiles. One can measure if your statistics is on the ordered level of measurement. Then if you're going for a relationship calculation, you can go for a rank difference correlation, because again you have got two sets of data which are ranked, so you can see whether there is a what you call relationship is there or not. And statistical significance methods for hypothesis testing would end up in only non-parametric methods like I-square or man-with-new or which are the tests, but definitely not any parametric test like t-test or f-test. So this is what you call possible statistics can be done through a measurement when it's in the form of ordered level measurement or ordinal level of measurement. Then we'll move on to the next level, what you call the interval scale. See how we are improving. Initially the data was haphazard, so that's why we just nominated them. In the second level, what we did is we tried to put them in the order. So once we tried to put them in the order, the drawback there was the gaps or the intervals are not same. So that kind of deficit is made clear in the third level of measurement called as interval scale. So in interval scale, what we do is the intervals are adjusted in terms of some rule so that it is established as a basis for making the units equal. For example, the best example for interval scale is if you have got a centimeter scale with you, a 15 centimeter scale, the difference between 1 to 2 centimeters is exactly equal to difference between 7 to 8 centimeters. The difference between 1 to 2 centimeters is exactly equal to half the difference between 6 to 8 centimeters. Now, whatever the calculations you do, now the interval would be remaining exactly same. The gaps are maintained same. The intervals will not vary. So that is why it's a third level of measurement. Now we are coming for a kind of measurement which is becoming more precise compared to the first two levels of measurements, nominal and ordinal level of measurement. But it has got one major drawback. So a major drawback here in interval scale is it lacks a true zero. It doesn't have a true zero. The zero is arbitrary. The meaning here is when you talk about arbitrary zero, we say zero is not fixed one. Zero is a fluctuating zero. That's why we say example would be for an interval level of measurement is a temperature. When you talk about the temperature, remember the reading can go to minus 10 degrees, minus 20 degrees. But try to understand such measurements still under interval scale because it is not still a perfect scale because the ranges have gone or the values have gone beyond zero. Then once the values have gone beyond zero, please see that that measurement is not a very good. Why? Because the measurement has gone what you call minus. So any measurement with the minus, still the statisticians would not consider as a good measurement, though we get such measurements in analysis. So that is why what you call lack of true zero is there. So still it is at the third level. Uh, the idea here is major idea is it cannot measure a complete absence or a complete presence of a trait or a characteristic. So that's the idea. It cannot measure total absence of a variable or total what you call trait or a characteristic. You cannot say zero. You cannot say what you call some of the personality is zero. No. Temperature which goes to minus. So not a good measurement. So that is why we may have to go to the next level. So we'll see some of the examples. Interval scale responses. As I said, an interval scale has all the properties of an ordinal scale, and the difference between the scale values can be meaningfully interpreted. It's been measured numerical scale, and the measurements in between the intervals are same. So we call sometimes called as equal appearing intervals. So when you have equal appearing intervals, it can best fit the interval scaled responses. So for example, now you see 70, 80, 90 or IQ score 40 to 60 and 100 to 160. So whatever it may be, the idea here is it is much better than the previous two one, but it lacks a true zero. That is a problem. The zero is beyond zero, that is minus. So again, I'm repeating, any value is the minus is not a good statistics. So what could be the article or any other example? Suppose I ask a question, how likely are to buy a new automobile within the next 6 months? So you have following what you call measurements 1, 2, 3, 4, 5, 6. So, but you can again you see still we call it as a what you call a interval scaled responses because we lack a true zero. It cannot measure complete absence of a trait. So with this, what are the possible statistics can be managed? Now, so far we did not speak about central tendencies of a mean. Remember, in the first level we talked about mode. In the second level we talked about median and mode. And at the third level, we are going to talk about mean. So once we talk about mean, try to understand we are going for more precise nature of statistics. What is happening with the mean? If you remember, a mean is a condition or a score which can be represented by several scores, and you calculate a single score, which was not possible earlier. So here we are going to calculate mean as the appropriate measure of central tendency. when it comes to measures of variability, standard deviation could be the prime importance, because I'm going to talk about later measures of variability and dispersion. That time I'm going to talk about importance of standard deviation in research. Now you can apply a product moment correlation. Remember, in the previous version, we started applying only rank difference correlation, but now we can go for a product moment correlation. Then when it comes to the what you call difference based test, you can apply t test and f test, where you can use ANOVA or you can use t test. So these are the things where you can use as possible statistics under interval scaled responses. Now, since we have got a what you call lack of true zero, or zero is arbitrary, still our measurement is incomplete. Since our measurement is incomplete, we go for the next level called as the ratio scale. So the ratio scale has the complete what you call spectrum of analysis, where your measurement starts with exactly 0.00. There's nothing like minus value. So it has got absolute or true zero of measurement. For example, if I measure weight, it exactly starts with 0.00 kg, then the weight is placed, then accordingly the deflection would come by the weight. But remember, the weight we adjusted to 0.00 kg, then depending on the weight, the deflection of the needle would come. But that is a very true measurement where there is no minus weight. Likewise, number of staff in a what you call in an institution, there could be no staff, that is zero. There could be 10 staff, yes, there could be 5 staffs, whatever it may be, where in terms of numbers or your own income could be a good example for ratio scale. So, but remember here the true zeros would be there, and now you are completely open to do what you call a good statistics. So that's the idea. And the possible statistics would be, now as we talked about earlier, now it is much more what you call improvised, and you can do more statistics. Preferably now you can even get into a parametric statistics types, where measure of central tendency would still remain as mean, but there could be geometric and harmonic means can be calculated. Along with the SD, you can calculate CV and standard error too. You can go for product moment correlation instead of rank difference correlation. And test for statistical significance are the t test and the f test. So this also would be there. So we'll be discussing more about t test and f test, all those things. Then we'll think about a simply a summary. See how the precision increases. Nominal data, if you improvise that, it will lead to ordinal data. Ordinal data further can be improvised to interval data. And the ratio data is the ultimate type of data which you can get. But as I said, nominal data and ordinal data, they serve like a qualitative data. Whereas interval data and ratio data, they serve as quantitative data, where true weightage scores are being given to ratio data to interval data. But in nominal data and ordinal data, the weightage issue will not appear, though the numbers look double, but actually they are not double. So that's the idea. So in a nutshell, a nominal data represents categories, okay, but it doesn't have any order or direction. Whereas in the ordinal data, the same categories are put in the order, rankings, order or scaling. At the next level, because while ordering, the intervals are not clear, that interval is made what you call very clear in this one, but there is no true zero. So that's why you go for the final level. Difference between the measurements are made specific. True zero definitely exists. So we will go from nominal data to ordinal data to interval data to ratio data. Now please understand all the researchers there, because nowadays the idea here is for your appraisal and your promotions, people, when your application is verified, they look for articles and they look for your publications, and that time you have to publish in UGC care or some Scopus or web indexed journals or PubMed also. So that time you have to publish a quality paper, and to publish quality paper you need to have a quality content, and statistics also should be done precise. So unless if you are not knowing the nature of data, if you apply some haphazard statistics, so then your paper may not be accepted. So the
ನಾವು ಇಲ್ಲಿ ಬಿಡ್ರಿ ಇಲ್ಲ ನಾ ಈಗ ಆನ್ ಮಾಡಿಲ್ಲ ಬರ್ರಿ ಪ್ರಕಾಶ್ ಅಂತ ಬಂತು
95 Sri Shail, I think it's your microphone is on. Sri Shail, kindly mute. Okay, so all those researchers and all because you need to publish articles, you need to improve your academic credentials. So in such cases, please be aware of what type of data you have. Without knowing what type of data, it's very difficult to manage next what kind of statistics to be applied. So that's where type of data and measurements, I'm just stopping it here. Before moving into the hypothesis and other issues, if there are any doubts, please ask regarding the types of data. And if you're not understood, I don't mind repeating it again, because I'm talking about very basic issues. Because if you understand this, then it's easier to understand the later issues. Any doubts, please feel free to ask. Any doubts? No doubts? If there are no doubts, we'll move on to the next level article. Now you understood what is the data, what are the types of data, how to measure them. Now another idea here is you can convert this one ratio data into interval data into lower levels. For example, suppose you're taking students marks, like you have 70, 80, 40, 50 such marks you have. You can convert into ordinal or nominal data by reducing them to categories. For example, first class. So anything above 60% is first class. Anything fail is below 35%. Below 35% is what you call fail. Now you can categorize them. Then once you categorize them, then it becomes ordinal data because you have categorized them. But remember, whenever we do that, try to understand we are trying to reduce the data. So ratio data and interval data can be reduced to ordinal or nominal data, but reverse is not possible. Nominal ordinal data cannot be transformed into ratio or interval data. Sorry, getting my point? Now, for example, when you talk about socio-economic status, and if you take income, now when income, you can have 70,000, 80,000, 1 lakh, 2 lakh, 3 lakhs, whatever the number of persons having different levels of income. So you can later you can categorize them. Those people who have got less than 1 lakh, between 1 lakh to 2 lakh, and 2 lakh plus. Now that means what? You have converted data from ratio to ordinal data. This process is downward process is approved in conversion of data, but directly or nominal or ordinal data cannot be what you call converted into interval or ratio data. In a way, parametric data which is observed under ratio and interval can be converted into qualitative data called as non-parametric data. But non-parametric data cannot be transformed into parametric data. So that's the idea. From here you can convert to down, but from here you cannot convert into the top level. So that's the idea where we are going to talk about. So this is just a brief summary. So with this, I think hope we are clear about the types of data and all. Now we'll slowly move on to the hypothesis and hypothesis formulation, one of the important things in research. Now remember, whenever what you call we talk about a hypothesis, this is based on the objectives and hypothesis formulated. So when we talk about a hypothesis, since it's offline class, I cannot ask you many questions. So when you talk about hypothesis, the hypothesis formulation basically comes through review of literature. Please make a note. The basis for hypothesis formulation is a review of literature. Now that is why many times you must have asked why review of literature is required. But please try to understand that review of literature is a very important aspect of your thesis or your report or your dissertation, where it gives lot of insights for hypothesis formulation, because that gives the what you call idea that what has previously happened in your field of research, and specifically in your what you call specifically for your title which you have made, whether there are related studies are there, and now you get to know what is the what you call major findings in those studies, and those findings and what you call other aspects of the study will lead you to for hypothesis formulation. Based on their findings, you try to formulate your hypothesis for the research. But again, it goes by what you call some rules and regulations. But remember, for hypothesis formulation, the basis is the basis is
ನಮ್ಮ ಹೆಸರು ಶ್ರೀಶೈಲ ಹೆಸರೇ ಇಲ್ಲದ್ರಾಗ ಅವ್ರು ಬಂದ್ ಮಾಡಿಬಿಟ್ರ ನೀವು ಮತ್ತೆ ನೀವು ಇದು ಮಾಡ್ಕೋಬೇಡ್ರಿ
95 Srishail 95 Srishail participant number 95. Okay, so we need to what you call formulate the hypothesis for your for your thesis or for your project or research issue. Now my question is whether hypothesis is must for a thesis or for a report. Is hypothesis must, or you can go without hypothesis?
Yes, I say must.
Huh?
In literature, they can go without hypothesis, I think.
No, because usually, madam, we formulate a hypothesis in the beginning of the research.
Yes.
So is this is must, I am asking.
Yes, sir.
Yes,
It's a must.
it is must,
Yes,
but
it's a must,
in
it's a must.
humanities,
Okay, I have a small corrections for you here. Sometimes formulation of hypothesis is very difficult because you may not have a very good review back in your hand. So in such cases, what we do is we go for research questions. Are you getting my point? So instead of hypothesis formulation, we go for research questions, because there is a threat with the hypothesis formulation. Remember, if you formulate a hypothesis, at the end, you have to verify the hypothesis. To verify the hypothesis, you have to apply inferential statistics. And either you have to apply what you call any type of parametric or non-parametric statistics, and then you have to accept or reject the hypothesis. Now, sometimes what happens when you talk about rejection of the hypothesis or acceptance of the hypothesis, there are some rules occur. For example, if you formulate a null hypothesis, it is expected that you have to reject the null hypothesis. Please make a note. If you formulate a hypothesis in the format of null hypothesis, they are supposed to be rejected. So in a way, null hypotheses are meant for rejection. And there are another two types of hypotheses are there, alternate hypothesis and directional hypothesis, where they are meant for acceptance. Hope you are getting my point. Null hypotheses are usually formulated and later they should be rejected. This is the statistical way to write up. Whereas alternative and directional hypothesis to be accepted. Sometimes it is not possible to reject the null hypothesis and accept the alternative or directional hypothesis. So thereby you might commit two kinds of technical errors called as type 1 and type 2 errors. So try to we'll discuss what is this type 1 and type 2 error maybe tomorrow. But the idea here is when we talk about type 1 and type 2 errors, please understand when you are what you call presented with the type 1 and type 2 errors, that means you are not followed the sound research methodology. So that is the idea. So try to avoid type 1 and type 2 errors in your research. But this is basically comes when you are failed to reject a null hypothesis and fail to accept alternative or directional hypothesis. Now remember, as I said, forget about research question. Where in the research question, you need not verify the research question, but you have to just answer the question whether there is a difference. You say yes, there was a difference. Whether there is a relationship, no, there was no relationship. So you are very specific about answering this the research question. But when you formulate a hypothesis, you have to either accept or you have to reject it, or your results should support it, or your results should not support it. So this is where we are going to talk about hypothesis. And hypotheses are basically three forms: a null hypothesis, alternate hypothesis, and direction hypothesis. But usually when do we formulate null hypothesis? So the formulation of null hypothesis comes when you got minimal level of information, or when you try to something new where you cannot take any chance that something would happen, or there could be relationship, or there is a difference. So you will be having little vary about your ideology. So that is why, and if you are going to start something very new, I would advise you to go for a research question rather than a hypothesis, because you are more safe. So in null hypothesis, we say information is less or something is new. We'll have one example later so that it will be easier. And in alternate hypothesis, you have plenty of information, but it is not conclusive evidence is existing. Some studies says yes, some studies says no, some studies say there is a relationship, some studies say there is no relationship. You have studies, but you have no conclusive evidence or conclusion can be drawn. So it's a mixture of studies. So in such cases, you are going to use alternate hypothesis. And when it comes to directional hypothesis, your results are sure shot. So the meaning of directional hypothesis, you're telling what exactly is going to happen. That means you know the results in advance. Now we'll discuss one by one. So for example, when you talk about a null hypothesis, when we say null hypothesis of no difference or no relationship. So what is the meaning of no difference or no relationship? Can you take one example? So we take the example of one difference base, because hypothesis can be done either on base of a difference or on the basis of relationship. So only under two bases we are going to make a hypothesis. So we start with the null hypothesis. I'll take a very general example so that everybody can understand. So under null hypothesis, I say boys and girls do not differ in their academic achievement. Are you getting my point? Boys and girls do not differ significantly in their academic achievement. So in alternate hypothesis, what I say is, I say there is a difference. Now boys and girls differ significantly in their academic achievement. In null hypothesis, I said boys and girls do not differ. In alternate hypothesis, I say they differ. So then what happens to the directional hypothesis? Anyone there? Now directional hypothesis, as I said, your results are sure shot and your directionality of results is very specific. Can anyone talk about the directional hypothesis based on this? Null hypothesis, boys and girls do not differ. Alternate hypothesis, boys and girls differ. So what could be the directional hypothesis in this case?
Sir, boys score better than girls.
Dr. Sabina madam speaking.
Yeah.
Okay, madam. Now I think you are little you are right. But what is our literature review of literature is telling so far?
Girls score better.
Okay, okay, we'll put a condition up to PUC.
Yeah.
Up to PUC, I can say girls excel boys, or girls achievement is significantly more than boys. Why? I put a rider called as up to PUC. Why? Because since my day of awareness of reading newspapers, it is becoming the 10th results or PUC results. I have never seen this time boys excel. I have never seen that result. I never seen, to be frank. So my review of literature is so strong. so that I can say even 2023, whether it's SSLC or PUC, it is girls are going to excel boys. That means what? Boys pass percentages would be less and girls pass percentage along with the merit is high. I'm not telling from my own what you call intention. My statement has come through a strong review of literature. So are you getting there? First, there is no difference. Then there is a difference. Then comes, where is that difference? Now get into the what you call relationship based testings and related to hypothesis. So we start with the relationship. This one again, I'm going to the students level only. More the what you call mobile usage and academic achievement are not related. Extent of mobile usage and academic achievement scores are not related. Null hypothesis. Can anyone state in alternative form? Can anyone can state in the alternative form? Rajeshri madam?
There is a difference between
Yes, there's a difference
mobile
between.
usage, mobile usage and
Madam, there is
academic
now I'm talking
performance.
about relationship
Mobile usage and scores are dependent
or dependent or related to each
each
other.
other.
Okay, now once initially you said there is no relationship. Now you are telling there is a relationship. Now what happens to directional hypothesis? Where you are showing the directionality of the results very specific. How you are going to do that? Now we should be very directional. Okay, if you are finding it difficult, let me finalize it. More the usage of mobile, lesser the academic achievement. Earlier I said there is no relationship. Then I said there is a relationship. Now I am telling what kind of relationship. Or I can what you call state in a different way. Mobile usage and academic achievement scores are inversely related. The inverse means what? Negatively related. More the usage of mobile, lesser the academic achievement. Lesser the usage of mobile, higher could be the academic achievement. So are you getting the point? How we are going to state?
Yeah.
Whether it's alternative, whether it's a null hypothesis or direction hypothesis. But remember, usually null hypotheses are meant for rejection. Alternative and direction hypotheses are meant for acceptance. So either it's a difference or it's a relationship. Be aware of that because you need to formulate. Then next few minutes we'll discuss before the first session is over. How to prepare a what you call hypothesis, because hypotheses are very important. Later we have to what you call decide about the test. So before you start or formulating the hypothesis, what is that question is there in your mind? That is more important. If the question is not clear in your mind, hypothesis formulation is very difficult. And remember, a hypothesis is a statement, not a judgment. So many times the hypothesis looks like a judgment. Your hypothesis cannot be a judgment. It should be only a statement stating either there is a difference, either there's no difference, or where is that difference, or either there's a relationship or no relationship, or what kind of relationship. It is not a scientific question of the project. We say it's an educated testable prediction, because you cannot have some fancy hypothesis. Later you should test them. Please understand. So a fancy hypothesis would not be useful. So whenever you formulate a hypothesis, the hypothesis should undergo for verification. To verify the hypothesis, you have to apply a test statistics. Then hypothesis should be very clear. Okay, it should be written in clear and simple language. Okay, and hypothesis would direct you to measure the variables. That is also important. And if you are not clear about the hypothesis in the beginning, you will not be clear later also. And next, what are the variables you have to keep in your mind? That is also more important, because either you have to establish the difference between the variables, or you have to establish a relationship between the variables. So this is where you have to be very careful in what you call keeping the variables in your mind. Then testable hypothesis, to accept or reject. Okay, You need to able to do manipulate the situation or experiment, or you have to collect the data and either you have to see whether they are related or whether there's a difference. So, but remember, is your hypothesis testable? If it is not testable, you're wasting your time. Then to do that, try to understand, you will need to carry out, do the test. You should identify the variables and you must have included the independent and dependent variables in the hypothesis. That is also important. Now, whenever you make a hypothesis, please see to that it has got a proper meaning, because sometimes the hypotheses are only half. Sometimes I've seen the hypotheses are cut. No, that cannot be a good hypothesis. A good hypothesis should fulfill what is the expected results. That is more important. So once you talk about the expected result, that means what? Through hypothesis, you are predicting the results in advance. It may happen or may not happen, but you are predicting the results in advance, that what will happen at the end of the data analysis, whether the stated hypothesis, whether they are accepted or whether they are rejected, or whether your results support that or whether your results do not support that. So now you think of whether you are going for what you call a research question or whether you are going for a hypothesis. And remember, hypotheses are important, but there is no rule that you have to put the hypothesis all the time. Instead of hypothesis, you can always go by your research through research questions. But remember, whether you have made a research question or a hypothesis, your idea is you have to what you call verify them. The verification comes through inferential statistics, and sometimes descriptive inferential statistics we cannot directly do. We have to start with the descriptive statistics. So to do the descriptive statistics, there are several ways, which will be our discussion point in the subsequent session, in the next session. In the next few minutes, we are going to check what you call, now we know how to do the hypothesis and all. Now we'll slowly get into the applications of statistics. So this is also more important. When you talk about the application of statistics, it can be put under broadly three categories. One is under research, one is under academic or career significance, and lastly, the community level policy making. Now, for example, when I talk about research, so you have got your what you call PhD or MPhil degrees or postdoctoral degrees, or somebody's eyeing for DLit or DSc degrees. Research is very important. So statistics can be used very much in the research part. Not only for getting degrees, you want to publish articles, you require research, and statistics is the backbone of research. So to do that, as I said, academic and career, those who are working in the as teachers, definitely you require statistics, especially on a lower level, if not on advanced level, because nowadays most of the journals would seek for what you call validation of your findings through statistics. So you have to validate your findings, your data collection and all through statistics. And as I said, in academic and career also, you require promotions and all. To get promotions, you need to publish, and to publish and to get a project, you need to have statistics in your hand. So that is why it's one more application. And many times application of statistics comes at community level policy making. For example, today if you are seeing a bicycle scheme for children or high school students in the rural areas, it is because of the statistics. For example, on a simple level, if I am explaining you, when a research was done on rural students, why the dropout rate or the absenteeism was high. So they found that they're involved in other jobs, so they don't get enough time to spare for education. So that give the idea of a bicycle scheme. If you provide the bicycles so that they can go to the college or school and study well and come back fast home and again work at home. Now this is nobody's what you call one flash idea, because this somebody has done a research. Why absenteeism? or it could be a midday meal scheme. Remember midday meal scheme, why it was initiated? Why majority of the people who are availing midday meal, especially in the poor or backward areas and poor regions where they don't have enough to eat, and that is why to secure the food they have to go for other work, menial works. That's why the absenteeism rate was high. So if you provide some food in the school, automatically children will come to the school, and thereby at least for food sake they'll come, and thereby the punctuality or attendance also would increase, and thereby our purpose are indirectly served. So that is why our statistics can be useful even at the community level policy making. Your own research might open up some what you call policy making in the future. We don't know. You may have contributed better, but for all that, what you call statistics is important. So with this, we'll have 1 or 2 minutes for your question sessions. I'll put an end for the first session. Maybe after the break, we'll go to exactly for descriptive statistics. So before that, if you have got any questions, feel free to ask.